Hello, everyone, and welcome to MOS Live Ask a Scientist. In just a few moments, we will be meeting our educators who will answer all of your questions about space. My name is Christina. I'll be serving as your moderator today. And although you can see me now, you'll mostly be hearing my voice in the background as I share your questions and observations with our educators today. If you do have a question and you'd like to ask it to the educators, you can do so by clicking on the Q&A button at the bottom of your screen if you are watching on Zoom. And if you need captions, you can get those on Zoom by selecting closed captions on the bottom of your screen. If you happen to be watching on Facebook or YouTube today, unfortunately, we will not be able to see your questions or comments, but we're so happy that you've joined us for the program and we hope you enjoy the show. Now, all of that being said, I would like to invite our educators to turn on their cameras, introduce themselves, and today they're going to start by sharing their favorite place in space that has water.
Hi, everyone. My name is Eric. My pronouns are he, him, and my favorite place that has water is Mars. Used to have a whole lot more, and we're finding more and more evidence the more robots we send there that Mars used to have a ton of water and was entirely different. So I'd be happy to talk all about Mars today.
Hi, everyone. My name is Janine. My pronouns are she and her, and my favorite place in space besides Earth that has water on it or in it is Europa, which is one of the moons around Jupiter. I think it's really cool. It's well outside of the habitable zone, so where we expect to find liquid water in our solar system. But there's all this liquid water underneath, we think, and I'm just so excited about thinking about the physics of that and a moon, an icy moon out in the distant, far, far away from us that still manages to have liquid water.
And my name is Meg. My pronouns are she and her. And while I love both Mars and Europa, my favorite place in, that we know of that has water in space is the moon. And just recently, there's been some news about a new place on the moon that they have found water in sunlit portions, actually, of the lunar surface. So it seems like dating back to when the telescope was first invented, and one of the first things anyone even looked at was the moon. People have speculated whether there could be water there. And over time, though the initial reaction was that no, there's definitely not, it's definitely a dry place. We have seen again and again that there are places on the moon where water can exist, including most recently in these little nooks and crannies, even in the sunlight. So that fascinates me.
Excellent. These are all really great places to share. So thank you, everyone. And I think for our first question, we're going to just kind of start off with thinking about how things move in space. And specifically, when we hear words like gravity and inertia, what exactly are those things?
That's a big question. So gravity is a force that is associated with the amount of mass something has. So it's influence and its ability to attract something else to it by how much mass it has. So every single thing in the whole universe that has mass has gravity, but the more and pulls on everything else. But the more mass you have, the more you can pull on something. So while the Earth is pulling on me and keeping me seated right now, I'm also pulling on the Earth just a tiny little bit. But a cool place where you can see this kind of gravitational dance happening is actually with Pluto and its biggest moon, Charon. I would argue that they're a binary dwarf planet companion system and that Charon is not a moon of Pluto, because instead of Charon orbiting Pluto, they're both orbiting a barycenter, so a point where there's equal mass in between them, which is just really cool. So gravity is a force that is associated with how much mass something has, and I'll let someone else answer inertia.
I can take a stab at that. So inertia is sort of like, it's sort of like when you push something that's very heavy and it's starting to move because of that force that you just gave it. Inertia is the tendency for it to continue that motion. So that's a very complicated way of saying things, that are being acted upon by forces tend to carry through that motion or that response to that force based on how much mass they have and how much force was applied. So when you hear that word, it's just think about when somebody when you're swinging on a swing, or you're grabbing somebody by the hand and you're spinning in a circle, safely, of course. And when they let go and you fly off in a direction, you're carrying with you a bunch of the inertia that the two of you generated by the forces that you applied.
Awesome, thank you. That might be helpful if we talk about other kinds of motion in space today. And for our next question, it comes from Tiffany, age 11, who it's kind of long, so bear with me here. When thinking about Mars, when do you think humans can be staying there? A year, maybe a few years? And do you think we'll be staying there long enough to actually establish one of those sci-fi colonies?
I really hope so. We're working on getting humans to Mars all the time. Right now, we have robots that are exploring there. A whole lot of robots, actually. Some of them are orbiting around. Some of them are driving around on the surface. Some of them are halfway to Mars. They're on their rocket. They haven't got there yet, but they'll be the most technologically advanced ones. And then we're hoping that getting a human space program that visits the International Space Station, which is closer to home, and then we figure out how to go to the moon and live there in a permanent base. These are all things that build up from every different direction the technology and the knowledge we need to get to Mars. How much longer will that take? I hope sometime next decade, maybe in the 2030s, maybe in the 2040s. I certainly hope that we'll all be alive to see it happen. And how long we'll stay there has a lot of different ways to look at it too. You need to stay for at least a certain amount of time. You can't just stay on Mars for 2 months and then decide to go home, because Earth and Mars have moved around the sun and it's not so easy to get back anymore. And plus, it takes 6 months just to get to Mars. So you probably don't want to stay for 2 days and then have to go back home for 6 more months. So it could be that astronauts will spend 6 months there or a year there. And then, yeah, the eventual hope is that one day we'll have a permanent settlement. We'll be able to build a base. We'll be able to keep humans safe. We'll be able to have 2 planets that humans permanently call home.
Yeah, and I think it's interesting to think about all of the problems that scientists and engineers and anybody really who wants to participate and need to solve for us to go there, right? So you have to bring all of your food and maybe not all of your water, but probably a fair amount of your water with you. You have to make it so that you can exist on the surface. We can't breathe Martian air. Mars's air is mostly carbon dioxide. We don't breathe that. It's also a lot thinner. There's less gravity there. So one of the solutions we talk about is terraforming, which would take a very long time. Terraforming meaning making it like Terra or Earth, so making Mars Earth-like. So there, yeah, those challenges. If you've ever seen The Martian, he goes through a lot of thought processes about a smaller version of that, where it's not terraformed. Everything's kind of in domes, so that you can control a much smaller space of atmosphere. Yeah, I think that's a fun question to ask. I would love to see it happen, but don't send me there. I'll be happily staying here on Earth.
I definitely agree with you, Janine. I'm very happy on planet Earth. And for our next question, it comes from Eric, age 7, who would like to know, what are shooting stars?
That's a great question. Shooting stars are really awesome to see when you're out and looking up at the sky, and they're just like nature's fireworks when you're lucky enough to be looking in the right place at the right time. So always pay attention to what might be going on, because there are ways of predicting when you might see shooting stars. And the reason is because what's happening when a shooting star appears is there's actually a tiny fragment of a space rock or a piece of a comet or asteroid that has broken off and is so small that it doesn't make it all the way to Earth's surface, but it burns up in the atmosphere. And when it's doing that descent and it's burning up, it releases light. And that's what you're seeing for that magical moment when it's streaking through the sky. So there are particular times that are especially great for looking for shooting stars. And please jump in if you know of any particular dates, because none are coming to my mind at the moment. And that has to do with sometimes known comets that we know the orbit of. We know when they're likely to be coming toward the sun and releasing fragments that might intercept our own atmosphere. We can predict those kinds of meteor showers and then tell you to go outside and look up on a particular night and hope that it's not cloudy and that you'll get to see a really spectacular show.
I'd like to add one of my favorite tidbits about meteors, which are shooting stars, is that there's kind of 3 phases of the lifespan, right? So when they're out in space and they're just little hunks of things, they're meteoroids. And honestly, the only difference between a meteoroid and an asteroid is size. So if you're 20 kilometers and bigger, you're an asteroid. You're smaller than that, you're a meteoroid. When you're burning through our atmosphere, have all that friction, heating up, glowing, being awesome, really cool to look at, you're a meteor. And then if you hit the ground, you're a meteorite. So meteoroid, meteor, meteorite.
And the best time to look for them coming up is December 13th and 14th. That's when the Geminid meteor shower peaks. Go outside as late as you can. After midnight is better. It's one of the best ones of the year for how many meteors happen, how often they happen. It's the most active one. But it's also in the middle of December, which means you're going to go outside and lay on the ground. And then after 5 minutes, you're going to go inside whether you saw a meteor or not. So there's another one in the summer that happens that is almost as good, but much nicer to be outside. So we'll have to wait a couple more months for the coolest show if you don't like sitting outside in the cold.
And I'm glad you brought that up, Eric, because 9-year-old Eric, that was his follow-up question. So that actually helps quite a bit. For our next question, Troy, age 12, would like to know, how many stars are there in the universe?
So we've got one star in our solar system, and our Milky Way galaxy, heading out to the next step in our address in the universe, is made up of hundreds of billions of stars, just like the sun. Some are a lot bigger, some are a lot smaller, some are a lot brighter, some are teeny tiny and dim, but maybe 200 billion of them. And that's just our one galaxy. The next step out in our address would kind of just be the universe, where there's hundreds of billions of galaxies, each one of them having hundreds of billions of stars. So now we're talking about something like a quadrillion stars, maybe a few quintillion stars. It's really mind-boggling. The thing you hear most often when trying to imagine how many stars there are in the universe is that every grain of sand on the Earth, on every beach on the entire planet, has one star in the sky somewhere. So imagine every single grain of sand, count them all up on the whole entire Earth. That's how many stars are in the universe.
Yeah, and I just want to share this picture, hopefully. This is the Hubble Ultra Deep Field. Every speck, pretty much, except for the ones that look like a Christmas star, like that cross with a cross through it, is a galaxy. This picture is of a very, very, very small part of the sky. So if you held a grain of sand out at arm's length and looked at the sky, that's how much of the sky that is. And these are all galaxies. So for reference, crazy amount of stars.
That's a very cool picture. Thank you for sharing, Janine. And I realize there's maybe a connected question, since we're using some words that might not be familiar to folks. And Isora, age 9, would like to know, what is a universe?
I like how you phrase it, a universe, because we're usually used to thinking about the universe, which is the one that we know and love and are familiar with. It encompasses everything that we know and understand in our experience, our existence. So that includes all of the planets in our solar system, all of the sun, all of the stars in our galaxy that Eric just mentioned, all of the galaxies that exist in our local area and throughout what we know as the universe. It also includes some things that we can't see and that are very, very mysterious, but make up a lot of the mass that exists, especially something called dark matter. which we know exists because of the observations of gravity. Going back sort of to the first question, that we know that things behave a certain way in response to gravity, which depends on the mass that something has. And when we compare everything that we see with light that's coming towards us from the farthest reaches that we can see, the interactions, the way that things are moving can't be explained just by all of the matter that emits light that we can see. So we know that there's also some component out there that we can't see. And together, these two big components make up everything in the universe. And I'll just say, it's funny to think about it as a universe because there are lots of theories and also lots of really wonderful speculative science fiction out there that wonder whether ours is the only universe, or could there be some way that universes branch off depending on different choices that you make in life, or things that could have gone a different way. And that is one of the fun open and very just mysterious things that science is still, seeking to answer. And it's, to be honest, it's a reason why I went into science in the first place. It's just like so cool to think about. It's not what I ended up studying, and because there's just so many other cool things too. But if you want to think about the multiverse, there's a lot of different aspects of that could be really fun to research and or just read recreationally.
That sounds like a lot of fun, Meg. I often think about the multiverse too. It's just a fun word to say and a crazy concept. But thinking about how vast the universe is, our next question comes from Sam, who would like to know how many solar systems are in the universe? Is there even a way to quantify that?
I'd be happy to let someone else jump in here, but we don't know exactly how many solar systems there are, but we have a lot more information now than we did, let's say like 10 years ago, because we now know we have seen other solar systems besides our own. And just by looking at as many of those as we can start to make guesses about how likely it is that any given star might have a solar system around it that we can't see. And it turns out we think that it's extremely common throughout the universe for there to be many, many solar systems.
Cool. And for our next question, moving away from the universe, sort of, right now, we have a question from Elizabeth, who wants to know, why is the sky blue in the day?
That's a great question, and it's one that is up there with the most asked questions of all time, and it has to do with our air and the sun. So the sun is where we get all of our light, and the sun gives off light of every single color. It gives off yellow light and green light and blue light and red light. If you've ever seen a prism, that's something that's small in glass. It can split light up. It splits the light up into lots of different energies. Each one of those energies has its own color. A rainbow is the same exact thing, except it's water drops in the air that are splitting up all that light into its different colors. So you can see the red light and the blue light and the green light. And it turns out that when the sunlight from our star passes through air, some of the bluer light gets scattered around by that air. It's coming in from one direction, right from the sun, and the blue light bounces around and hits the air molecules and goes in every direction. We call it scattering. And the rest of the light keeps going and makes it to our eyes. So no matter which way you look in the sky, there's always some blue light from the sun bouncing off air in that direction and then hitting your eyes. So what ends up happening is blue light is coming at you from every which way, and that means the sky kind of looks blue. When the sun gets lower in the sky, you may have noticed the sky doesn't look blue anymore. It starts to look yellowish and then orange and red. That's because the sunlight has to travel through more air as the sun gets lower because of the angle that it's moving through our air. And that means that not just some of the blue light, but some of the green light gets taken away, and then some of the yellow light. And that means more red light is getting bounced everywhere. And our sky looks a little bit different. And the atmospheres on other planets look different. If you go to Mars and look up, it's kind of like a butterscotch yellow brownish color. And as the sun gets lower in that sky, it turns blue and it looks a little bit more like home.
And you can look at pictures of that. So if you Google like Mars sunset, because the rovers have taken these pictures and that's how we see it. So I totally recommend. Very cool to see the sky on another planet.
Awesome. Well, thank you for that. And our next question, it is partially science, or maybe it's like a pop culture inspired by science. We have Tiffany, age 11, who's noticed that a lot of times people, like famous people, superstars, rock stars, pop stars, we use that terminology of star a lot for people who are like very famous or well known. Do you know why we compare ourselves to stars? And I might throw in there, do you think it's a accurate representation of that?
Oh, I don't know for sure why it is, but I can hazard a guess. And I would think it's because stars are so bright and brilliant. And when you look in the sky, you notice them and you want to stare at them and they're beautiful. And just like you can't not look at them, right? Especially the sun, but don't look straight at the sun. We said this every time, but it's really bad for your eyes. Don't do it. But they're so bright and they can light up things around them, right? So I think that's why we end up with pop stars, right? We want to stare at them. They're beautiful. They're kind of special. There's some mystique about them that we don't quite understand, but they stand out. And I don't know about whether or not it's a good comparison, but it's certainly. So I would be interested in it if in other languages people use that same term. So
I'd be interested in that too. I always love the adjective stellar, just because it comes from the root that means star, but it means, like super excellent. And so I can't help but just think that somebody who is at the top of their career, like a pop star or superstar, is, just really stellar at their job. So it's, in that sense, I think you totally put it a really great way.
And I would add that it's interesting that stars, they don't necessarily live forever. And just like a pop star or rock star, they may see their light kind of slowly fade away, which brings us to our next question from Eric, age 7. Hello, welcome back, Eric, who would like to know why do some stars explode? And he also asked if the North Star will explode.
So when stars are just in the middle of their life cycle, that we call it, they're burning fuel. They're mostly taking hydrogen gas, which is the most basic, simple element of the universe, and they are squeezing it. The middle of a star is so dense and so hot that it's kind of taking two hydrogens and putting them together into a helium. And it gives off a tiny little bit of energy. And it does this so many trillions of times per second that the total amount of energy is huge. Now, stars start with a whole big, huge amount of hydrogen, but they burn through it. Just like a car burns through gasoline, a star burns through all its hydrogen, and then it can't have that fusion in the middle. It can't take two hydrogens and put them together. And so that means its energy is exhausted. Some stars, like our sun, the smaller ones or the medium-sized ones, will run out of fuel, and then a couple different things will happen. It will basically expand to get bigger and cooler, and then some of the outer layers will kind of just float away into space, and what's left over will be a smaller, brighter star. But if a star is really, really big, it's a massive, huge star, then when it reaches the end of all that fuel, it doesn't just kind of gently let go of some of the layers. All of a sudden, that fuel isn't, the fusion in the middle isn't pushing out against gravity, and the entire star collapses and then rebounds all at once. And it's the most titanic explosion that we know of. We can see them clear across the universe. They're called supernova. And it happens because all that fuel is gone, and it happens dramatically. In a fraction of a second, the whole star just explodes. And they shine so bright that the ones we've seen on the Earth in the last 1,000 years have been ways we can date things. They've been major events. You could go out and read a newspaper by the light of this exploded star and the leftover light from that explosion that lasts for a couple of days.
Yeah, the other cool thing about supernova is we've got this fuel happening inside the star of the hydrogen to helium, and you can actually keep going with the helium to lithium and all the way up the periodic table until you get to iron, and then it takes more energy to make stuff than it releases, so it becomes really unstable and explodes, right? But with supernova, so anything else you find on the Earth past iron, it came from a supernova, because it's the only time that there's enough energy and compression, I guess, to create these other elements. So anytime, if you looked at a periodic table and you counted up the numbers and you got to iron, anything after that, all those other elements came from a supernova.
Supernovas are so fascinating. So thank you for sharing those cool facts. And I'm looking at the time, and it looks like we might have time for one last question. And I was actually curious about the very exciting news we saw this week with NASA's SpaceX crew and astronauts officially arriving at the space station, and was wondering if you all could tell us a little bit about how long those astronauts might be there and what is their primary focus or mission that they'll be focusing on while they are there.
So those 4 astronauts went up last weekend, and they are NASA astronauts as well as an astronaut from the Japanese Space Agency. They went up with SpaceX, like you mentioned. That is a private spaceflight company that was contracted by NASA to bring astronauts up to the space station in 2014. They did it for the first time earlier this summer, and then they just did it again. This is the first operational one. The previous one was a test, with just 2 astronauts making sure all the systems worked out. These astronauts are going to stay long-term on the space station. So that's a very long time, 6 months, 7 months. And what they do up there is take care of the space station, because it's kind of a really old, aging structure. It's now been continuously occupied by humans for 20 years. And that means there's a lot of replacing of solar panels, upgrading of computers, they're changing the air filters. There's a lot that happens that has to be done. There's also a lot of science. It's one of the most unique laboratories anywhere on the Earth or off of it. That weightless environment, being in space and orbit around the Earth, means you can make materials like crystals grow differently than you can on the Earth. You can study our human bodies and how our bones and muscles and immune systems and brains and eyes all change in space. There's so much research that can be done. And the most exciting thing about this news is that they were sending up 4 astronauts and not 3. So all of the boring stuff gets taken care of the same amount, but with an extra astronaut, now we have another person who can be dedicated just to the cool science stuff. Growing plants, measuring blood pressure, taking telescopes and sticking them on the outside of the space station and seeing things. So many cool things will be able to be done with an extra pair of hands up on the space station.
Awesome. Well, thank you so much to our educators for answering all of our questions today. We are just about out of time, so I want to thank Eric and Meg and Janine, and you all can say goodbye to our audience.
Bye.
Bye, everyone.
Bye. Thank you.
And I want to thank all of you today for joining us for the program. And if I wasn't able to get to your question today because we ran out of time, thank you for your patience. What I can say is that we do have multiple programs going on each week. If you would like to try to ask more questions about space or other topics, you can check out our schedule by visiting all of our offerings virtually at mos.org/mos@home. And if you enjoyed this program today and you would like to support the Museum of Science, you can learn more about how you can do that by visiting our website at engage.mos.org/welcome. Thank you all for joining today. We hope you have a good afternoon or evening, and we'll catch you at the next one.